All right, this is at THS Mr. Jones with chapter 0.5, which is rational expressions. Okay, so I first want to start off by what is a rational expression? So we know that a rational number is any number that can be put into a fraction. Okay, so we're going to say instead of rational, we're going to put the word fraction. And expressions are just one side of an equation. So it does have variables. So we'll say fractional variables. Okay, that's what a rational expression is. So for example, maybe I have 2x plus 3 over x squared plus 3x minus 1. Okay, it's fractional and it has variables in it. Okay. Now, one really important thing we must do with rational expressions are restrict the domain. Okay, and what that means is to find values that x or your variable cannot be. Okay, and this step is easy. Okay, now we have fractional exponents, or sorry, fractional variables. So let's say I have 2 over x minus 1. Okay, now with fractions, this down here cannot equal 0. Okay, so what would make this 0 is if x equaled 1. Okay, if x was 1, I'd get 0 on the bottom, which I cannot have. So we'd say x cannot be 1, and I have now restricted my domain on x. And that's all it is. You're looking at the denominator, you're finding out what x cannot be, and you're simply stating that. And you'll see that in most of our steps here. Okay, so steps to simplifying. Okay. Is factor everything. So you're going to factor, we come back up here, you're going to factor the top, factor the bottom. That's pulling out the greatest common factor. That's the special rules, whether it's a difference of squares or cubes, or it's the rainbow method, or it's whatever those methods we talked about in 0.4, you're going to apply to both the numerator and the denominator. Step 2 will be restrict the domain. Okay. And then step 3 is simply cancel. Okay. Super easy. So factor everything, restrict the domain, and cancel everything. So both of the number 2, the restrict domain, would be part of your answer. So if I look at one here real quick, let's just look at x squared over this. Okay, so factor everything. So factor the top, and your factors of 2 that subtract a 1. That's 2 and 1. Sign it different. The bigger one is positive. Okay, and then down here we're just factoring out a greatest common factor, which is that. Okay, so now I need to restrict the domain. So I'm going to look at the bottom here and figure out what 0 can't be. So nothing will make that a 0. A 1 will make this a 0. So we're going to say x cannot equal 1. And then we're going to do step 3, which is cancel. So I have x plus 2 over 2. And x cannot equal 1. Okay, you have to restrict the domain before you can cancel. Okay, now again, you cannot cancel these 2's because of the addition. So multiplication. All right. All right, so that's simplifying. How about steps to multiplying and dividing? All right, so step one, and I kind of split this up a little bit. Step one and two are the same for both of these. So you're going to factor. And when I mean everything, that's numerator and denominator of both fractions. You're going to restrict the domain. Okay. Now, for multiplying, now that we've factored everything, we've restricted our domain, you're going to multiply straight across. Let's just say group factors. Because you're not actually going to do the multiplying, and I'll explain that in class. And then you are going to cancel. Okay. For dividing, once you've restricted the domain, you'll multiply by the reciprocal. Okay. And when I say multiply, I mean group factors, but you got to flip that second one. Domain. Okay, you may have, because we're flipping that second fraction over, we may have some new x values to add to the do not use list. So cancel. So let's put that as group. Okay. So you'll multiply by the reciprocal or just group them together. So again, factor everything, restrict the domain, group factors cancel, because we multiply straight across, so we don't actually want to FOIL all of that out. And then we will, if we divide, we'll factor everything, restrict domain, group, or multiply by the reciprocal, and restrict domain, and then cancel. So one of your questions here is, what are the steps to multiplying a rational expression? Okay, that is one of your questions. Another question is, what does it mean to restrict the domain? Okay. All right, moving on. And subtracting. Okay, step 1 and 2 should be familiar. You're going to factor. Okay. Step 2 will be restrict domain. Okay. Step 3 will be find common denominator. Okay. Step 4 will be add or subtract. The top or the numerator. Step 5 will be factor top and cancel. Okay, so you're going to refactor that top and see if anything cancels. Our answer will have everything factored out when we are finished with this. Okay. We also have complex rational expressions, and this is fractions within fractions. Okay, so the way we do this is we work innermost we work the innermost fractions out. So we start on the very inside and we work our way out, restricting domain as we go. Okay, and I'll show some examples of that in class. So it looks like that's it. So our last question here will be, what are the steps to adding or subtracting rational expressions? So adding or subtracting. Here are your suggested problems. Most of you could probably go ahead and get started on this. If not, we'll talk about it in class. This is your stopping point. This is at THS, Mr. Jones signing off. If you want to stay watching, I'll go over some examples for those of you who need some extra help in class. Okay, we're going to go back to the beginning here and talk about how to restrict the domain. Okay, so it's pretty simple if you can just look at it, but we want to take whatever is on the bottom. Okay, take whatever is on the bottom, and that cannot equal 0. Okay, well, what number would make this equal to 0? Okay, well, in this case, I can't even factor this. Okay, so no matter what number I put in here, it's always going to be positive. It'll either be 2 or negative 2. 4, and 4 plus 4 is not 0. So this has no domain restrictions. Okay? So no restrictions. Okay, let's say I have something like this. Okay. So we'll set the bottom not equal to 0, and in this case, x cannot equal 4, and that is my restriction. Okay, and we'll see this as we keep going on through some of these. Okay, I did one problem with just simplifying an expression. So let's look at this one. Okay, our first thing was to factor everything. So factors of 2 to subtract to 1, it's 2 and 1. Signs of difference, big one's negative. Factor out a greatest common factor. Okay. So we want to restrict the domain. So looking here at the bottom, we'll set it not equal to 0. Well, I know x can't be negative 1 because this will be 0, and there's no variable over here, so that doesn't matter. Okay, and then we cancel. So then we have we have x minus 2 over 2 and our domain restriction. Okay, so you can factor and just simply cancel things out. So if we look at maybe this one, okay, so again, I factor both the top and the bottom. So any factors of 6, I subtract the 1. That's 2 and 3. And they're different. The bigger one is negative. Factors of 2, they subtract a 1. That's 2 and 1. Bigger one is positive. Okay. Domain restrictions right now, before you cancel. Okay. So right here, I can't have a 1, and right here, I can't have a minus 2. That's part of your answer, so make sure it's circled. If you don't put that on the quiz, you will miss a point. Okay, and now I just cancel. So I get x minus 3 over x minus 1. So I can find them. Okay, let's do one more of those. So we have x squared minus 4 minus x. So this one's already factored out. We might want to rewrite that. So it'd be minus x plus 2. I probably want to factor out a negative here because we never have that x to be negative. Okay, so there we go. This is a difference of squares, so it'll be x plus 2, x minus 2. Okay. We'll go ahead and restrict our domain, so x cannot be a positive 2, because I'll get a 0 there. Okay, and then we cancel. So cancel, cancel. Give x plus 2 over, and since this went away, but I still have that negative, it's a minus 1 on the bottom there. If you wanted to write this a little bit differently, we could write negative x minus 2 in the top, with x cannot be 2. Okay, either one of those solutions will be fine for me. Okay, let's multiply. Okay, so the steps in multiplying were factor everything, restrict the domain, and then group everything together, and then cancel if there was anything. So let's look at a multiplication problem. X plus 1, 4x squared plus 4x times 3 plus 3x squared plus 2x, and 9x plus 3. Okay, so we got to factor everything. Now, when I do this, sometimes I'll just write the factors above it, but maybe some of you need to just completely rewrite it. Okay, so we'll factor everything. So this one is fine. This one has the greatest common factor of 4x, so we'll get rid of that. That's with x plus 1. This one has the greatest common factor, and this one has the greatest common factor. So let's do the bottom first. So that's a 3, and I get 3x plus 1. Okay, up here, we're going to go ahead and take that out. So get x squared plus 3x plus 2. So x, set up our parentheses. I need factors of 2 that add to 3. That's 2 and 1. Okay, signs are the same, they're both positive. Okay, and we are all factored out. We will restrict the domain. So x cannot be, just start here. This is 0, would be a 0. 4 times 0 is 0. What makes this factor 0 would be minus 1. That doesn't have a variable, so it doesn't matter. And this one would be negative 1/3. Equal to 0 and solve it. So subtract 1, divide by 3. Okay. Now, in order to multiply fractions, we simply multiply straight across. So I can kind of do this, and they're already grouped up. Okay, and then we will go through and cancel. X plus 1, x plus 1, 3x plus 1, 3x plus 1, that x and that x. So it looks like we have x plus 2 in the top, in the bottom. That's it. Okay, so let's look at dividing. Because dividing is very similar, except you're doing a different operation. So it's definitely not the same. Okay, so the first thing is factor out everything. Okay, we notice we have a difference of squares here. So that's x plus 2, x minus 2 over x divided by, okay, we got a greatest common factor here of 3x. Factor it out, you get x squared minus 4, which is also a difference of squares. So you have 3x, x plus 2, x minus 2. And then you have 5x to the third. Okay, so right now, Okay, I can't have a 0 over here. And on this one, I also can't have a 0. So there's no need to put that twice. So now what I need to do is multiply by the reciprocal. So I'm going to multiply, but then I'm going to flip this one over. So you have x plus 2, x minus 2 over x times 5x to the third over 3x, x plus 2, x minus 2. Okay. Now notice when I flip this over, I got new numbers on the denominator here. So I need to add these to my restriction or make sure they're already included. So 3x can't be 0, and then x plus 2, I can't have negative 2, can't be 2. So there's my domain restriction. And then we're just back up here to multiply. So you multiply straight across, put some more parentheses in if you need to, and then cancel. So cancel, 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 cancel. Okay, I have 3 x's in the top, but I have 2 in the bottom. So that one and that one cancel with 2 in there. So you have 5x over 3 plus your 3 domain restrictions. Okay, so that's multiplying and dividing. We're going to look at the harder one, which is adding and subtracting. Okay, in order to add or subtract, we must have a common denominator. So the first step is factor everything, which these don't need to be factored. Okay, the next thing would be we can restrict the domains. So in this case, x cannot be negative a half because you subtract 1 divided by 2 and a positive 1. And we always want to keep this over here because in case we have to add something, we can. Now, I got to get a common denominator, and the easiest way to do that is multiply them by each other. So this one needs 2x plus 1, 2x plus 1, and this one needs x minus 1. Okay, so leave the bottom alone. So we'll say x minus 1, 2x plus 1. But the top, because I have to add, I have to multiply all this out. 3x, that's your first, your outside, your inside, your last, plus, distribute this one, 2x squared plus x. Okay, notice nothing added to my restrictions. I got to combine like terms up here. So sometimes I just like to write it at the top. So you have x squared. You have 4x. Oh, sorry, that was a 5x. That's the one on here. Minus 3. Okay, and ask yourself again, factors of 3 that subtract 5. There aren't any. So we will write it out. X squared plus 5x minus 3, x minus 1, 2x plus 1. And there we are. We have added them together. So let's look at a subtraction one because subtraction gets a little hairy. So we have 1 over x squared minus 2 over x plus 1. So everything is factored out. You're going to restrict the domain. So x cannot be 0 here and minus 1 there. Okay. Find a common denominator. So that means an x squared. That means an x squared. X plus 1. X plus 1. So you have x squared, x plus 1 on the bottom. In the top, you have x plus 1. Now be careful here because you're actually going to distribute a negative 2 to the x squared. So you have minus 2x squared. Okay, so then we'll take this, negative 2x squared plus x plus 1 over x squared, x plus 1. You need to factor out this negative because the leading term cannot be negative. So 2x squared minus x minus 1 squared x plus 1. See if we can factor this. So I take 2 times the 1 is 2. Factors of 2 that subtract 1, 2 and 1. Luckily, they're prime numbers. 2 and a 1, so that's a 1 and a 1. Signs are different. The bigger one is negative, so minus positive. X squared x plus 1. Does anything cancel out? No. So that's your answer. And we will put x cannot equal 0 and minus 1. Okay. Be careful on this. Make sure you're factoring out at the beginning, and make sure you multiply all this stuff out, because it does get a little confusing while you're doing that. Okay. The last thing we had was complex rational. So let's look at this problem right here. We got x plus 1 over 1 plus 1 over x plus 1. So it's fractions within fractions. So we work inside. We want to keep restricting our domain as we go. So I can take a quick look here and say that x cannot be 0 and it can't be minus 1. And I will want to add to that as we go on. Okay, so let's look at the top here, and I can add these together. I got to get a common denominator, which will be x. So 1 is 1 over 1, but I'm going to multiply by x. So I get 2 over x plus x over x. Okay. 1, but I need x plus 1. So that's x plus 1 over x plus 1. So x plus 1 over x plus 1 plus 1 over x plus 1. My domain restriction, I can now combine. So 2 plus x over x over x plus 2 over x plus 1. Okay, now look here. This can also not be 0 because it is in the bottom. Add a minus 2 to my restriction. Now dividing like this is very simple. We're going to take my outside 2 and multiply, and my inside 2 and multiply. I call it outers over inners. So take your outside 2 and multiply. Over your inside 2 and multiply. Okay. And I can rewrite this to be x plus 2. Okay. Again, check. There's nothing new to add. You'll see that this agrees. I can't have minus 2. And the last step is cancel. So x plus 1 over x. Okay. All right. That's where I'm going to stop for lesson 0.5. Again, there are your suggested problems. Number 101 is your challenge problem. If you got questions, please let me know. This is at THS signing off.